Hello, welcome back everybody, Brain Gains here. In this episode we're going to be solving some problems on quadrilaterals. Let's dive right in. Alright, if the triangles are isosceles, what is the area of the quadrilateral? Alright, so we see that we have isosceles triangles of length 2, and what are these angle measures? That's really the question. Well, it makes a rectangle. Well, I'm actually really drawn over to the corner over here. If we can figure out this triangle, then we can figure out the whole problem. Here we have two isosceles triangles stacked up to one another. So this is also an isosceles triangle. And this is a right angle. And because this is an isosceles triangle, this must be 45 degrees, and this must be 45 degrees. So we have a 45, 45, 90 triangle. And what do we know about 45, 45, 90 triangles? We know that this side length is x, this side length is also x, and the hypotenuse is x root 2. This is a property of triangles. If you don't know this, go back to a properties of triangles video and watch some of those problems being solved. What is the length of our hypotenuse here? Well, we see that our diagonal is 2, and this is two of those isosceles triangles put together. So in this case, our hypotenuse is 4. So we see that x root 2 equals 4. And so x equals what? X equals 4 divided by root 2. Or in other words, this simplifies to 2 root 2. Alright, so we have this length is 2 root 2. So let me do some erasing. What else do I see? Well, I see that if we add some lines, this rectangle can be split into 6 squares. And we just found the length of from here to here, so we can find the area of this square, 2 root 2 times 2 root 2. Well, what is this? Well, this is just 2 times root 2 squared. 2 squared is 4, root 2 squared is 2, 4 times 2 equals 8. So the area of one of these squares is 8, and we have 1, 2, 3, 4, 5, 6 of the squares, and 8 times 6 is 48. So our answer for the area of this rectangle must be 48. Awesome. So knowing your properties of triangles really comes in handy in several places, and in a lot more places than just triangle problems. So be sure you know your properties of triangles. Alright, let's continue. Clear the board. ABCD is a quadrilateral with measurements of its sides shown in the diagram above. If AB is parallel to CD, what is the area of the quadrilateral? So what type of quadrilateral is this, first of all? Well, this side is parallel to this side. So we have one pair of parallel sides, so this must be a trapezoid. And then what do we know about the area of a trapezoid? Well, the area of a trapezoid is found by base 1 plus base 2 times your height divided by 2. So we already know our base 1 and our base 2. What we don't know is the height. So that is what we have to find. Alright, let me change colors here. So I'm going to draw a line, drop down a line from our base 1 to our base 2 on both of these sides. And we know the middle segment is a length of 10, Oops, change back to a pen. But we don't know this segment, we'll call it x, and we don't know this part, y. But we do know that x plus y must equal to 14. And we could probably make a systems of equation now and solve this problem. However, whenever I see triangles, I immediately think of our special right triangles. For example, I think of the triangles that I tell all my students you have to know about is you have to know about the 5, 12, 13 triangle, and you have to know about the 3, 4, 5 triangles. These Pythagorean triples are just must-knows just because they make solving problems so much faster and easier whenever you know about them. And so right here, I see this is 13, and so I'm going to assume, I don't know this for a fact, and I might be proved to be wrong and have to go back and solve it, but my first guess, my first instinct is to say that our height is 12. And then let's see if this will make sense. Well, if this is 12, then our x has to be 5. And that's again by this Pythagorean triple, 5 squared plus 12 squared equals 13 squared. And if this is 5, then our y value has to be 9, as 5 plus 9 equals 14. X plus y equals 14. And let's double check that this makes sense. Well, our 3, 4, 5 triangle, this is just 5 times 3, 12 equals 4 times 3, and 9 equals 3 times 3. So this is just our Pythagorean triple 3, 4, 5 scaled up 3 times. And so this works. So we have all of our values. So now let's plug it into our area of a trapezoid formula. We have base 1 plus base 2, 10 plus 24 is 34, times our height, which is 12, divided by 2. And so here I'll just go ahead and divide 12 and 2 to get 6, and then I'll multiply 34 times 6. So out to the side, we'll have 34 times 6. 6 times 4 is 24, put a 4, carry a 2. 6 times 3 is 18, plus 2 is 20. So I believe our answer here is 204. Let's see if this is right. I bet it is. Excellent, excellent work. So here is a great illustration as to why knowing these triples is just so valuable. It makes the amount of time you spend on the problem that much less. If this was like an SAT problem, this is a problem that could take a lot of time, but by knowing these triples, you go really fast. So that is where the value is. It's in saving time. All right, let's clear the board. Let's go to our next problem. In the above rectangle, all of the smaller shapes are squares. If the 2 green squares in the center each have side length 1, what is the area of the rectangle? All right, so this one, it looks like we're just going to be doing some counting. Let's change to a color. So each of these green triangles, let's zoom in on our shape. Each of these green squares rather have side length 1. So if this is side length 1, then this orange square has side length 2. And this blue square must have side length 3, as 1 plus 2 is 3. And so this purple square must have side length 5, as 2 plus 3 is 5. And so we have 2 plus 1 plus 5 here is 8. So our big red square has side length 8. So what is our final area? Well, we have a height of 8 times a length of what? 8 plus 2 plus 3 is 13. So what is 8 times 13? And I believe this is 104. We have 8 times 10 is 80, 8 times 3 is 24, yes, 104. Perfect. So what did I do there? What did I just do for the mental math? I split this 13 up into two problems. I split this up into 8 times 10 and 8 times 3, and then I just added them together. And this is 80 plus 24 is 104. So this little mental math trick comes in handy whenever you're multiplying things by 13. You might not know your 13 factors or multiples off the top of your head, but I would hope you know what 8 times 10 is, and I hope you know what 8 times 3 is, and then adding those is pretty simple. So our answer here is I'm going with 104. Let's check it. Excellent. Excellent. Next problem. If all the rectangles in the figures are squares, and the area of the shaded square is 25, find the area of the square ABCD. So here we want to find the area of the largest square. We know that the red shaded in, it has an area of 25. This color is not showing up too hot. Let's try this green maybe. A little bit better. Whenever we get off the red, it will show better. So we know this side length is 5 and this side length is 5. What about our next square? Well, the diagonal of our square is the diameter of this circle. And the diameter of this circle is also the length of our next square. So that is key. That is key. So again, this is a 45, 45, 90 triangle. So our hypotenuse for this triangle must be 5 root 2, as this is a special right triangle where we have x, x, and x root 2. So this hypotenuse is 5 root 2, which means the length for our next square is 5 root 2. And then what do we do to get the next square above? Well, we're going to do the exact same process. The length is 5 root 2, and so we'll find the hypotenuse, which will just be another root 2, and that will be the length of our largest square. So the length of our largest square is 5 root 2 times 5 root 2, and this value squared will be the area. And so what do we have here? Well, we have square root 2 times square root 2 is just 2. 5 times 2 is 10. And so this is equivalent to 10 squared, which is 100. So the area of our largest square is 100. Let's type our answer in. Fantastic. That was a fun problem. I love all these different shapes that are involved. It makes it really fun. Knowing about the diameter of your circle, seeing how that equals the length of the next level of the square, and how we can use our special right triangles to see that it's going to be 5 square root 2 and then another 5, then another square root of 2. All right, let's go on to our last problem. The length of the altitudes from a vertex of the parallelogram to the other two sides are 10 and 12. If the parallelogram has a perimeter of 176, find the area. Okay, so it's important that we know about properties of a parallelogram. Okay, we know that this side is parallel to this opposite side, and we know that the top side is going to be parallel to the bottom. We also know that this angle measure will be equal to this angle measure, and this angle measure will be equal to this angle measure. We also know that the top side will be equal to the bottom side, and the left side will be equal to the right side. So these are all the things we should know about parallelograms. And so what do we have? Well, if I just put a variable on it, I'll call my top and bottom x's and my left and right side y's. And we're told that the perimeter is 176, so I know that 2x plus 2y equals 176. And what else do I know? Well, what is this question asking for? It's asking for the area. Find the area. Well, what is the area of a parallelogram? Where it's just base times height, right? And so we see if we have y as our base, we know y times 12 is our area, and we also see that this must equal 10 times x. If we use x as our base, then 10 would be our height. And we should have our answer. So let's solve for x. We see that x equals 12y divided by 10 equals x. And so now let's plug it in to our first equation here. I'll change colors. Let me do some erasing. So we have 2 times 12y over 10 plus 2y equals 176. Here, I'll erase this now. So 2 times 12 is 24y over 10. And then I'm going to change this 2y to just be 20y over 10. And so this is 24y over 10. We're adding these together and we get 176. And so if we add these together and then multiply both sides by 10, what do we have? Well, we'll have 44y equals 1,760. And now to solve for y, we just need to divide both sides by 44. These cancel. Here, let me do the division up here. So we have 44 divided by 1,760. 44 goes into 176 4 times exactly. And how do I know this? It's because 4 times 40 is 160, and 4 times 4 is 16, and 160 plus 16 is 176. That's how I looked at that and knew it so quickly. We bring down our 0, 44 goes into 0 times, so this is 40. So our y value, our y equals 40. And what is our area? Well, our area is y times 12, base times height. So 40 times 12 is 480. Excellent. So this was that last problem. This was some quadrilateral problems. I hope you enjoyed. If you haven't already, please subscribe to my channel. It really does help. Send me a message, comment down below what math problems you would like to see solved. I'm here to help you out. Thank you so much. Until next time.